Hey, welcome everyone on today's training on Docker. Maybe you are a student, a new developer, or just starting out in DevOps. This is the session will help you building a strong foundation. We will look up at what is Docker, why it was created, and how it was work, and the commands you will use most oftenly. By the end of this session, you will understand not just what this Docker does, but why it matters. Let's get started. So, the problem before Docker. Before Docker, running software across different computers was hard. Code that works fine on developers' laptop would may often break once it moved to the test servers or into production. This happened because every machine was set up a little differently. Different operating system, different version, different settings. Team wasted a lot of time to fix these problems instead of building a new feature. Docker was created to fix that inconsistency. So, what is Docker really? Think of it like it's a shipping container. A shipping container can carry almost anything and by moved by truck and be moved by truck, train or ship without anyone needs to open it. Docker works the same way for software. It packages your application together with everything it needs, the code, the dependencies and all the settings into one neat package called container. Docker is a tool that builds, moves, and runs the containers so the app behaves the same way no matter where it is running. Now, what is a container? A container is a small, self contained space for an app that can run. Unlike a full computer or a virtual machine, a container doesn't need its own operating system. It borrows the one already running on the host computers. This makes containers very light and quick to start. Usually it just take a few seconds. Because they are efficient, you can run many containers on one machine at the same time, each one working independently. Let's compare containers and virtual machines since they really show why Docker is useful. A virtual machine includes a complete copy of operating system which makes it big and slow to start, often taking minutes. On the other hand, Docker containers skip the step. They share the operating system that's already on the host. So they are much smaller. They start in just a few seconds and you can run many more of them on the same computer. That is why container is more reliable and faster than virtual machines. Now, Docker has three main parts working together. First, that's the Docker client, which is what you use to type commands. Second, the Docker daemon, a background program that actually builds images and runs container. And the third, the Docker registry. It's like a Docker hub which store images so they can be downloaded or shared. When you are running a command, the client talks to the daemon and the daemon talks to the registry if it needs an image it doesn't already have. Let's walk through how Docker actually works step by step. It start with your application code. You will write a file called Dockerfile which lists the instructions for packaging your application. Docker reads the file and build a Docker image. Now thinking of it as a snapshot of your app, the image can be stored in a registry so others can use it. Finally, when you run the image, Docker creates a container and your app is up and running. That's how Docker works. Now, what is the difference between images and containers? People often mix up images and containers. So let's clear that up. A Docker image is like a blueprint or a recipe. It fixed template that describes your application. While a container is what happens when you actually use that blueprints to build something real. It's a live running copy of that image. You can create as many as containers from single image and each one runs on its own separate from the others. In other words, container is an instance of Docker image. Now understanding Docker files. A Docker file is a simple text file with instructions for building an image. Let's break down with a quick example. From that tells Docker which is the base image to start from. Here we are using a simple Nginx web server. Now copy. Copy adds application files into the image. Expose. Expose show which network port the app will use. And at last CMD. CMD tell Dockers what command to run automatically when the container starts. Every Docker file follows the same basic patterns. Now these are some important Docker commands you need to remember. Here are some commands you will use all the time to download, view images and etc. You will use Docker pull and images to build and start containers. You will use Docker build, Docker run and to check, stop or remove containers. You will use Docker PS, Docker stop, Docker RM. You don't need to memorize all of these right now, but you will get very comfortable with them over time as you use Docker every day. Let's talk about two more important ideas, networking and volumes. By default, each container is isolated and can talk to other. Docker networking usually through something called a bridge network allows containers to communicate with each other like a web app talking to database. Volume solves a different problem. Since containers can be deleted at any time, volume let you store data separately. So it says safe even after the container is gone. Most real application needs more than one containers. Maybe a web servers need a database and co-caching tool all working together. That's where Docker Compose come up. Instead of starting each container one by one manually, you write one simple file that describes your whole application, including each service and how they connect. Then, as with a single file, then a single command. Docker Compose up. Docker builds and start everything from at once. Now, Docker plays a big role in modern DevOps. Here's come example, a developer writes a code and push it to Git. Now, it triggers the CI/CD pipeline which automatically builds a Docker image, send it to a registry and deploys it. Because the container behaves the same way everywhere, teams get more consistent, faster and more reliable deployments. The same idea is also what makes tools like Kubernetes possible. So, where is Docker actually used? Almost everywhere it is used to build microservices where each small part of an app run on its own computer. It powers CI/CD pipeline by creating clean, fresh environments for every test. Developer use it to match the local setup with production. And it is used for cloud deployments, tools like Kubernetes, log systems like ELK, and quick database setup for testing. Let's quickly recap what we have learned today. Docker packages application into small, possible portable containers that runs on the same way everywhere. We compared containers with virtual machines, looked at how Docker's architecture work, and learned the different image between images and containers. We also covered common commands, Docker Compose, and how Docker fits into DevOps. If you remember one thing, remember this. If you want to remember this. Build once, run anywhere. That's how. Thank you so much for watching this video. If you have any related doubt, please put in the comment box. Thank you.